Machiel says test. Michael says test. Solaris 428 says it works. Weird Video Gamer says hello.
All right. Hello. I hope you're having a wonderful day so far. Welcome back into the stream. Hey, dude, how's it going? Welcome in. I hope you're having a wonderful day so far. Today, we are going to be diving back into our learning here. More specifically, we are going to be learning and continuing this calculus course. Going to try to get a chunk of it done. Going to fill out some of these squares today, which will be fun. As we've been learning about limits, and we've been learning about, as we approach certain different directions, as we, call certain functions within other functions and find those limits as we approach certain x values. So really, right, using direct substitution, all that kind of jazz. So anyways, we're going to continue on today with our note-taking and our learning here. Nice, dude. How's that going for you? Welcome back. Welcome in, Weird Video Gamer. Appreciate you for joining me again. How's it going, dude? All right, let's open up our independent mathematics here. All right. All right, we are on lesson 6 here. Let's go ahead and see what we're on here. Lesson 7 is what we're on.
Weird Video Gamer says it's going pretty good.
Limits by factoring. Nice, dude. Awesome. All right, you guys. Without further ado, let's just go ahead and get into this. All right, we're doing limits by factoring. So this is going to be our
f of x is equal to
Weird
x
Video Gamer
squared,
says thanks.
x squared plus x minus 6 over x minus 2. And we're curious about what the limit of f of x as
all right.
x approaches to is equal to.
Okay.
Now, the first attempt that you might want to do right when you see
Direct
something like this is
substitution.
to see what happens. What is f of 2? Now, this won't always be the limit, even if it's defined, but it's a good place to start just to see if there's
Mohan
something
says
reasonable
yes,
to think
Calc.
about. So looking at it this way, if we just evaluate f of 2, on our numerator, we're going to get 2 squared plus 2
Undefined,
minus
because
6.
they're going to get
It's gonna be
0 in
4
the
plus 2, which is
denominator.
6 minus 6. You're going to get 0 in the numerator, and you're going to get 0 in the denominator. So
Wow,
we don't have,
undefined.
the function is not defined, so not defined at x is equal to 2. F not defined. So there's no simple thing there. Even if this did evaluate, if it was a continuous function, then actually the limit would be whatever the function is, but that doesn't necessarily mean the case. But we see very clearly that the function is not defined here. So let's see if we can simplify this, and we'll also try to graph it in some way. So one thing that might have jumped out at your head is you might want to factor this expression on top. So if we want to rewrite this, we could rewrite the top expression, and this just goes back to your algebra 1, two numbers whose product is -6, whose sum is +3. Well, that could be
Mohan says
positive
I do the
2,
test I
so this
sent
could be
after
x
you finished
plus
the whole
3
limit. Real
times
quiz.
x minus 2, all of that over x minus 2. So as long as x does not equal 2, these two things will cancel out. So we could say this is equal to x plus 3 for all x's except for x is equal to 2, as long as x does not equal 2. So that's another way of looking at it. Another way we could rewrite our f of x, do it in blue just to change the colors, we could rewrite f of x, this is the exact same function, f of x is equal to x plus 3 when x does not equal 2, and we could even say it's undefined when x is equal to 2. So given this definition, it becomes much clearer to us of how we can actually graph f of x. So let's try to do it.
Okay.
So that is not anywhere near being a straight line. That is much better. So let's call this the y-axis. I'll call it y equals f of x. And then let's, over here, let me make a horizontal line. That is my x-axis. So defined this way, f of x is equal to x plus 3. So if this is 1, 2, 3, we have a y-intercept at 3, and then the slope is 1. The slope is 1. But it's defined, and it's defined for all x's except for x is equal to 2. So this is x is equal to 1, x is equal to 2. So when x is equal to 2, it is undefined. So let me make sure I can. So it's undefined right over there. It's undefined right over there. So this is what f of x looks like.
Nice.
Now given this, let's try to answer our question. What is the limit of f of x as x approaches 2? Well, we can look at this graphically. As x approaches 2 from lower values than 2, so right over, so this right over here is x is equal to 2. If we get to maybe, let's say this is 1.7, we see that our f of x is right over there. If we get to 1.9, our f of x is right over there. So it seems to be approaching this value right over there. Similarly, as we approach 2 from values greater than it, if we're at, like, I don't know, this could be like 2.5, our f of x is right over there. If we get even closer to 2, our f of x is right over there, and once again, we look like we are approaching this value. Or another way of thinking about it, if we ride this line from the positive direction, we seem to be approaching this value for f of x. If we ride this line from the negative direction, from values less than 2, we seem to be approaching this value right over here. And this is essentially the value of x plus 3 at x, if we set x is equal to 2. So this is essentially going to be, this value right over here is equal to 5. If we just look at it visually, if we just graphed a line, with slope 1 with a y-intercept of 3, this value right over here is 5. Now, we can also try to do this numerically. So let's try to do that. So if this is our function definition, completely identical to our original definition, then we just try values as x gets closer and closer to 2. So let's try values less than 2. So 1.9999, this is almost obvious, 1.99999 plus 3, well, that gets you pretty darn close to 5. If I
so it's just kind of he's just trying to hone in on the fact that although the limit is 5 for this function, it is actually undefined at 5, like in our rules.
We'd be even closer to 5. The limit here is going to be equal to 5.
All right, interesting.
Let's see if we can find the limit as x approaches.
Okay. Practice problems.
Tim says good afternoon, Mike.
Mr. Tim! Welcome back in, dude. Appreciate you for joining me again. How's it going, man? How is it going? Alright, you guys. We're pushing for 2,200 today. We're at 9 subs away. If you guys are here and new to
Tim
the stream.
says stop running from Mahan's quiz.
I ain't doing that quiz. Khan Academy is enough for me. If it ain't the Khan Academy, I ain't doing it. Alright. So we have this function here. So let's go ahead and do some math. Okay, so find the limit as x goes to 2 for this function. Well, we know, I'm terrible at factoring though. It's been a long time.
Tim says, we're not logging off until 2,200 subs.
So for this, do you just take out an x2 out of it? So you have x to the power of 4 minus 4x cubed plus 4x squared, right? All over x minus 2. Out of the top, do I factor out the an x minus 2 out of there? Or do I factor out an x squared out of there? Because do you have to do it, whatever you do at the bottom, or maybe not? I can't remember. It's been a long time since my algebra rules and stuff, guys. So if we factor out an x squared, that would give us x squared minus 4x plus 4, right? All over x minus 2. That really doesn't do much for us. So obviously, I think the goal here is to try to get this denominator to cancel, right?
Tim says I think you need to factor out the x2 since the x2 gives you a 0 in the denominator.
Yeah, that would make sense, right? So if instead of factoring it that way, let's factor it with an x minus 2 out. So if we factor x minus 2, oh boy. I'm not even sure, really. We might have to. So
Tim says so first you can factor out an x squared and then you can factor the x squared negative 4x plus 1, which is a layup.
okay. Yeah. Okay, so if we factor out the x squared first, that gives us x squared times x squared minus 4x plus 4. And then we can factor out we might take out x minus 2. Alright, so this would be, so what are the factor rules again? That multiplied to c and add to b. Okay, so we need to factor out that multiply to b, the c, and add to b. So negative 2's. Okay, so we
says
x squared,
out x squared from the
minus
top.
2, and x squared, and x minus 2. Okay, so then that would give you x minus 2. You can cancel out one of those. That gives you x squared
4x plus 4
times x minus 2 over 1, right? Which give you x cubed minus 2x squared, right? X cubed minus 2x squared. So then if we want to find the limit as we approach these values as we approach 2. So if you plug in 2 for that cubed, so we got 8 minus 2 times squared 4, which is 0 again out front. So no, I want to see.
Skewitch says, why are you learning calc, if I might ask?
Just for fun, just to learn. Why not? Right. So if we have,
Tim says to get into the PhD program at my school.
we have this, right? And if we say x is equal to 2 here, I got 0 for my function. So that is what I was getting.
Skewitch says,
Woo!
WHT massive waste of time.
Dubs, boys. Give me some dubs. Alright.
Skewitch says calc has almost no applications in CS. Victorio says, LOL cap this guy. Skewitch says, if you wanna do math, do lin ALG.
I'm tired of this guy. He comes in and tries to be all funny, and especially yesterday he was talking about my girl
Victorio
and stuff.
says calc Ike's probably the one math that has felt useful to me.
I don't know why he comes in here every single
Skewitch
day.
says new. Skewitch says lol. Tim says I'm laughing.
There he goes. Here's where losers go. Alright. Let's keep going. Hold on. Alright. Let's keep moving.
Tim says rip bozo.
Rip Bozo's right.
Betsim says learning calculus.
Yeah, what's up, guys? How's it going, man? Trying to teach ourselves here. Okay, next question. I just, it's been a long time since I had to do factoring, so I'm a little bit slower on this stuff. Last time I took a math class was 7 years ago. So we're going to -5. 10x squared plus 50x over x squared minus 25. Okay? So obviously we need to factor out to get the bottom to cancel, so that's kind of like our cheat here. So we can factor out.
Rodrak says hello.
So the factor rules are finding the greatest common factor between these two. Should be 10. That would take us to 5 there. But I need to get to 25, so I need to factor out by 2. So at the top I'll factor out a value of 2. Right, so this will take me to, I need to factor out the 10 completely. Interesting for this one.
Hinami Spy says Skewitch isn't wrong though.
Not really, dude. You gotta think about people's time. That's especially in spending however you want to do, dude. Why would I ever listen to some random on the internet about how I should spend my time?
Hinami Spy says true.
I don't think that guy has 2,000 subs after streaming every single day, teaching himself how to code and do math, so, I mean, proof is in the pudding. Alright, let's keep going here, guys.
Says remember difference of squares?
Yeah, I gotta remember these rules. It's been a long time, you guys. Just be honest. Okay, so
Konami Spy says, although I agree LinALG is more useful in CS, but do what interests you.
we'll get there. We gotta level up.
Victorio says us that on the bottom if we're stuck.
So let's look up difference of squares.
Tim says a CS major from my school doesn't graduate without Cal 3 or 300 level stats at minimum in math. Konami Spy says, YouTube is delayed compared to Twitch.
Yeah. The difference between squares is factoring pattern. Okay, so if we
Solaris
take
428 says, I have only seen LinALG in hard questions, like LeetCode Q4 or last question of ABC. Konami Spy says a good CS math path is Calc 1, 2 maybe 3 with probability and stats and LinALG.
So basic numbers, right? So as we go to exponents. So here we have.
Mohan says what's going on, is there argument I can handle it Mike LMFAO.
Just that gamed QHA skid. Trolling. Abandoned.
Solaris 428 says, however counting appears often.
So we want to look for the greatest common factor, right? We know that the greatest common factor would be 10 in this case. So let's just first forget about the bottom. So if we factor out a 10x from this, right, this would give us just 2x plus 5 in this case. But if we
Tim
want to
says,
match
don't
the
worry
bottom
Mohan,
of x
I
squared
already
minus
banned him.
25, which is
Solaris 428 says, sound is a bit loud.
So, oh, I forgot. Sorry, I was watching the video. So if we watch,
So the one from yesterday, I think, right?
yeah, I banned him. There's no difference in squares here because it's subtraction. Squares is a straightforward factoring problem, right? Okay, so then the thing is though, is if I have 10x times 5 times x plus 5 over x squared minus 25, I can't get rid of that.
Konami Spy says the bottom is a common pattern that can be factored.
So let's then factor the bottom as well. Okay, so let's keep going here. Let's say, okay, so the bottom one we can just do x minus 5 times x plus 5, and then that'll get rid of the x plus 5 in the numerator. So now we have 10x times x plus 5. Those would move those. So now we have 10x over x minus 5. So now if we plug in the negative 5 here, here, right, we have 10 times negative 5 over negative 5 minus 5 equals to negative 50 over negative 5 minus 5, negative 10, which gives us to just positive 5. Negative 50 divided by negative 10 gives me a value of plus 5, I think, here. Let's go over the math one more time. So we factor out the 10x, which give us 10x times x plus 5. We factor the bottom to give us x minus 5 times x plus 5. We reduce down to give us to 10x over x minus 5. We plug in the negative 5 here. 10 times negative 5 is negative 50. Negative 5 minus 5 is negative 10 to give us positive 5 here. Woo! Boom! Let's roll. That's what I'm talking about, boys. All right. Okay. So let's find here on this one, limit as x goes to negative 2 of x cubed plus 3x squared plus 2x over x plus 2. What's up? Okay. I'm having to deal with some trolls on here. I had to ban a guy.
What?
Yeah, he was trolling me. I'm tired of
That's
them.
cool. It's like a first.
Well, okay, so if we want to reduce this one down, obviously we can take out an x out of all of this. So if we take out just a simple x from the numerator, that gives us to x squared plus 3x plus 2 over x plus 2. Now, can we reduce down even further? We want to find a value that multiplies and adds, so this would be x times x plus 1 times x plus 2 over x plus 2. Cancel those. That gives us to x squared plus x. So now we plug in the limit of -2 for this. Or sorry, -2 squared plus -2. So this would be 4 minus 2 equals 2. So this would be 2. What do you guys think on here? What do you guys think? I got 2 for this one. Do we come to a consensus and agreement here? All right. I got 2 here. I'm gonna send it. Whoa. All right, next step.
Says Mike, show us your notebook.
A notebook. I have to. If you want, I don't want to have to write. I need to get like an iPad.
Glenn says, why are you learning calculus?
For fun, dude. Every time I stream myself learning calculus, I swear I've gotten like probably like 15 people come in here and tell me I'm wasting my time learning calculus.
Waste of time, LOL.
It's just like,
One step.
right? It's just like, I don't get it. When do people feel like they need to, like they're experts? I don't know. I mean, it's like, it's just. I don't know. It's like they're paying me to do this, so I'm on their clock.
You do whatever you want.
I'm on their clock. I'm on their time card.
Glenn says, did you not take it in undergrad?
Yeah, I took it in undergrad just 7 years ago. Just want to keep learning, so we're gonna keep going up to all the way through probably like linear algebra and keep going here. That's my goal. So -1 here. So now we're to x squared plus 12x squared. Or no, so that's 3x cubed. 12x cubed. Over x to the 4th minus x squared. Okay, we can reduce this down. Factor out the top. We can factor out a 12x squared to give us just x plus 1 over, we can factor out a x squared, but the thing is we need to invert this sign, so we need to factor out a negative x squared to make this negative x squared plus 1. Oh, hold up. Oh, wait, hold on. This is x squared, 12x squared times. Okay, so we factor out a 12x squared, that gives us x plus 1. If we then take out. So maybe we should leave. Maybe we should leave a, let's leave a value, let's try that again. So let's go, let's factor out, we want to leave that, we can only reduce the bottom, right, down to if I do that again, negative x squared times another negative x squared plus 1, right? So if I need to reduce it down to there, I've got to take out the 12 x squared, but that gives me just a singular x value. Huh. Okay, so we take out the 12x squared, and we take out an x, we can only reduce this down, we take out an x squared, gives us x squared minus 1. But if I were to take out an x squared here, I get an x on the top. Well, if in this case that you can't reduce it down, well, maybe, is there a different way I'm not thinking about? Not plus 1.
Mohan says, Mike, if anyone told you Calc has no app in CS, they are just bad props. Skip all classes and maybe vibe code or nudes. Lin ALG is more common, but Lin ALG is pillar of all math. That's like intro to math.
Yeah, I know, dude. I know. It's...
Nuts says lol.
Okay, so this one. On this one, you guys, so if I plug in, how can I get the bottom to cancel out here? If I factor out a x squared, a 12x, I just don't have the same ratio, so I can't factor out the same amount of x on the top and the bottom.
Mohan says that's why I told you first learn Lin ALG or do together, but Calc 1 is not that big of a deal to start with, without Lin ALG.
Nah, man, it's more of like a life goal thing. Just want to get good at all of them. Just independently go through all the steps, and I'm in no rush. I have a job as a chemist, make good money, don't need to be struggling over what subject matter to teach myself based off what some people on the internet say. I'm just streaming this for fun. I could be skateboarding right now or playing guitar, enjoying my Memorial Day, but I'm teaching myself calculus. Okay, so let's talk about this one. So I am having trouble with this. Let me take this. What I got.
Mohan says, LOL imagine.
Okay, so hold on. So if you do take out a x squared out of the... If you...
Solaris 428 says, ETW you should check Wolfram Alpha in case you don't know it yet.
Okay, so we have...
Mohan says bro doing math on holiday.
Let's walk through this one. So on the top, we can factor out like I did. We can factor out a 12x squared and get just x plus 1. And then on the bottom, we can factor out the x squared to give us x squared minus 1. And then we can make this x squared minus 1, we can factor this one down even further to be 12x squared on the top times x plus 1 over, so this will be x squared times x minus 1 times x plus 1 Now we can get rid of the x pluses, one on the top and the bottom. Now we're left with 12x squared over x cubed minus x squared. Which is interesting, because then I can also factor out the x squared, right? Because that is technically just 12 times x squared. So I can get rid of the x squareds and have 12 over x minus 1. So if I plug in a negative 1 here, negative 1 minus 1, this gives me 12 over negative 2, which gives me to negative 6. Woo! Nice. Okay, I just got to remember that you can go further if you have x squared minus a singular 1 value, or whatever x squared minus, you can factor that one down, like in the previous problem. Okay, that was 4 for 4. Woo!
Mohan says Mike, a trick plug the number, this case minus 1, and see what's wrong if is 0 slash non-zero lim is 0 if is non-zero slash
Okay.
0 is INF, DNE if is 0 slash 0 you know.
Okay, let's keep going here.
Let's see if we can find the limit as x approaches negative 1 of x plus 1 over the square root of x plus 5 minus 2. So our first reaction.
So what's this called? This is called limits by rationalizing. This is limits by using, so lesson 7 is, this is lesson 7. I need to get some better notes here. I need to go back and take better notes. I'll have to update my notes. So this is limits by rationalizing.
Might just say, okay, well, let's just use our limit properties a little bit. This is going to be the same thing as the limit as x approaches negative 1 of x plus 1 over the limit, limit
quotient
as
properties,
x
okay.
approaches negative 1 of square
this
root of
function
x
here.
plus 5 minus 2. And then we could say, all right, this thing up here, x plus 1, if we think about the graph y equals x plus 1, it's continuous everywhere, especially if x equals negative 1. And so to evaluate this limit, we just have to evaluate this expression at x equals negative 1. So this numerator is just going to evaluate to negative 1 plus 1.
0.
And then our denominator, square root of x plus 5 minus 2, isn't continuous everywhere, but it is continuous at x equals negative 1. And so we can do the same thing. We can just substitute negative 1 for x. So this is going to be the square root of negative 1 plus 5 minus 2. Now what does this evaluate to? Well, in the numerator we get a 0, and in the denominator, negative 1 plus 5 is 4. Take the principal root is 2 minus 2. We get 0 again. So we got 0 over 0. Now, when you see that, you might be tempted to give up. You say, oh, look, there's a 0 in the denominator. Maybe this limit doesn't exist. Maybe I'm done here. What do I do? And if this was non-zero up here in the numerator, if you're taking a non-zero value and dividing it by 0, that is undefined, and your limit would not exist. But when you have 0 over 0, this is indeterminate form, and it doesn't mean necessarily that your limit does not exist. And as we'll see in this video and many future ones, there are tools at our disposal to address this, and we will look at one of them. Now, the tool that we're going to look at is there another way of rewriting this expression so that we can evaluate its limit without getting the 0 over 0? Well, let's just take this, so let's take this thing right over here, and let's say this is g of x. So essentially what we're trying to do is find the limit of g of x as x approaches negative 1. So we could write g of x is equal to x plus 1. And the whole reason why I'm defining it as g of x is just to be able to think of it more clearly as a function and manipulate the function, and then think about similar functions, over x plus 5 minus 2, or x plus 1 over the square root of x plus 5 minus 2. Okay. Now, the technique we're going to use is when you get this indeterminate form, and if you have a square root in either the numerator or the denominator, it might help to get rid of that square root. And this is often called rationalizing expression. In this case, you have a square root in the denominator, so it would be rationalizing the denominator. And so this would be, the way we would do it, is we'd be leveraging our knowledge of difference of squares. We know that a plus b times a minus b is equal to a squared minus b squared. You learned that in algebra a little while ago. Or if we had the square root of a plus b and we were to multiply that times the square root of a minus b, well, that'd be the square root of a squared, which is just going to be a minus b squared. So we can just leverage these ideas to get rid of this radical down here. The way we're going to do it is we're going to multiply the numerator and the denominator by the square root of x plus 5 plus 2. Right? We have the minus 2, so we're going to multiply it times the plus 2. So let's do that. So we have square root of x plus 5 plus 2. And we're going to multiply the numerator times the same thing, because we don't want to change the value of the expression. This is 1. So if we take the expression divided by the same expression, it's going to be 1. So this is square root of x plus 5 plus 2. And so this is going to be equal to x plus 1 times the square root of x plus 5 plus 2. And then the denominator is going to be, well, it's going to be the square root of x plus 5 squared, which would be just x plus 5, and then minus 2 squared, minus 4. And so this down here simplifies to x plus 5 minus 4 is just x plus 1. So this is just x plus 1. And it probably jumps out at you that both the numerator and the denominator have an x plus 1 in it, so maybe we can simplify. So we could simplify and just say, well, g of x is equal to the square root of x plus 5 plus 2. Now, some of you might be feeling a little off here, and you would be correct. Your spider senses would be, say, is this definitely the same thing as what we originally had before we canceled out the x plus 1s? And the answer is, the way I just wrote it, it is not the exact same thing. It is the exact same thing everywhere except at x equals negative 1. This thing right over here is defined at x equals negative 1. This thing right over here is not defined at x equals negative 1. And g of x was not. So g of x right over here, you don't get a good result when you try x equals negative 1. And so in order for this to truly be the same thing as g of x, the same function, we have to say for x not equal to negative 1. Now, this is a simplified version of g of x. It is the same thing. For any input x that g of x is defined, this is going to give you the same output. And this has the exact same domain now that we've put this constraint in, as g of x. Now, you might say, okay, well, how does this help us? Because we want to find the limit as x approaches negative 1. And even here, I had to put this little constraint here that x cannot be equal to negative 1. How do we think about this limit? Well, lucky for us, we know that if we just take another function, f of x, if we say f of x is equal to the square root of x plus 5 plus 2, well, then we know that f of x is equal to g of x for all x not equal to negative 1, because f of x does not have that constraint. And we know if this is true of two functions, then the limit as x approaches the limit, let me write this down, is, since we know this, because of this, we know that the limit of f of x as x approaches negative 1 is going to be equal to the limit of g of x as x approaches negative 1. And this, of course, is what we want to figure out. What was the beginning of the problem. But we can now use f of x here, because only at x equals negative 1 that they are not the same. And if you were to graph g of x, it just has a point discontinuity, or removable discontinuity, or I should just say a point discontinuity right over here at x equals negative 1. And so what is the limit? And we are in the home stretch now. What is the limit of f of x? Or we could say the limit of the square root of x plus 5 plus 2 as x approaches negative 1? Well, this expression is continuous, or this function is continuous at x equals negative 1, so we can just evaluate it at x equals negative 1. So this is going to be the square root of negative 1 plus 5 plus 2. So this is 4, square root, principal root of 4 is 2. 2 plus 2 is equal to 4. So since the limit of f of x as x approaches negative 1 is 4, the limit of g of x as x approaches negative 1 is also 4. And if this little I guess you could say, leap that I just made right over here doesn't make sense to you, think about it visually.
Okay.
Think about it visually. So if this is my y-axis and this is my x-axis, g of x looked something like this. G of x, let me draw it. G of x looked something like this, and it had a gap at negative 1. So it had a gap right over there. While f of x would have the same graph, except it wouldn't have the gap. And so if you're trying to find the limit, it seems completely reasonable. Well, let's just use f of x and evaluate what f of x would be to kind of fill that gap at x equals negative 1. So hopefully this graphical version helps a little bit, or if it confuses you, ignore it.
Interesting. That was a bigger leap on some of these. All right. All right. Okay, interesting on that one. We'll definitely probably need some practice here. Let's start rationalizing. Okay, so, oh, that makes sense. Anything other than 0 divided by 0 is undefined. 0 is indeterminate, which allows you to manipulate it into other forms. I never understood whether or not I'd be justifying and manipulating an expression like this into a nicer form. Apparently, it's justified when the numerator is 0. I always see the algebraic manipulations immediately when I see a problem like this. Why is manipulation permissible when the numerator is 0? Instead of going through rationalization process to find the limit of g of x is reasonable to replace x with something. Because we can expect the answer to be clean integer for approaching. Is there any way for us to say the function is continuous or not? Interesting. Okay. So limits of using conjugates. Okay. This might take us a little bit longer to get through here. Okay, on this one, so we have the limit as x goes to 4. Right, let's get some tunes going here. My bad, y'all. All right. So then we have 2 minus the root 4x minus 12 all over x minus 4. Okay. So we need to reduce this root down, get rid of this root, obviously. Okay. So if I go and do what he did before, and I say, okay, this is this function, right, multiplied by the is it 2 plus what did he do in that video?
A minus b squared.
So the property of power squares. So he said times 2 plus the square root of 4x squared, or 4x plus 12, or minus 12, sorry, over x minus 4, or so times there on the bottom as well. Okay, so that gives us 4x minus 12 times, or negative 4x or minus, so it goes 1 minus that. x minus 4. If I factor out a 4, or so then I combine like terms 4x, 12, negative 4x plus minus 4. Now I take out a negative 4, gives me x minus 4 over x minus 4. Ah, shoot. Damn, I don't think I did this one right. Okay, so let's walk through this on the whiteboard, you guys. We'll do this one, and then we'll switch to programming. Okay, so we have 2 minus the root of 4x minus 12 over x minus 4. This becomes, we're going to multiply this, right, by, so this is actually, right,
Mohan says, did you multiply the to 4 times and minus 12?
this is negative root 4x minus 12 plus 2. So I need to multiply this by negative
Mohan
root
says it will become plus 12.
4x minus 12 minus 2. Next, this is a negative. I need a positive. So I think it's my signs that I'm goofing up here. So this is what this means, right?
Mohan says plus SQRT.
So then we need to inverse this sign, inverse that sign. Gives me the next one. This will be times 4x minus 12 plus 2, right? So then we get negative 4x minus 12 right, and then we multiply 2, negative 2, so we get minus 4 over why did I then negative 4x minus 12 minus 4. Okay, so then we multiply the denominators. puts us into a square root situation. That's what we want.
Mohan says Mike multiply into minus 12. Mohan says it's 2 cat 2, 4x 12.
X minus 1. Right. So then we factor these out. So it reduces down to negative 4x minus 16. That. And this gets interesting because now if I factor out a negative 4, I get x plus 4 here. But I have x minus 4 on the bottom. Well, maybe I didn't do the signs right again. Let's go back here. So we have 2 minus 2 minus the square root of 4x minus 12 over x minus 4. So what I'm going to do is I'm going to multiply this entire function by the inverse. Or so what this is actually saying is this is saying negative square root of 4x minus 12 plus 2 over x minus 4. So now I'm going to multiply this by I want to see the sign. That's the one part I'm getting confused on, is the sign of what we multiply it by. For this one, the sign for the square. Okay, multiply by the conjugate.
Chat Mike.
So multiply by the conjugate. So then this becomes... Okay, so I did it right my first time. Ah, crap. Okay, so then if I did it... So right, this is what we do here. We're going to say... two minus the square root of 4x minus 12 over x minus 4, right? We'll multiply that by 2 plus the square root. So this is what I did the first time. Maybe I just did the math wrong. Right? So this gives us to 4x negative 4x minus 12 right. Hold on. This is that. So 4 minus 4x minus 12 over x minus 4.
Mohan says, again.
So now we can reduce this down
Mohan says
to
plus 12 Mike.
right. So the negative is outside of here. So now this reduces down to 4 x plus 12 here. Right, and then this carries over. So now we have negative 4x plus 16. This. Right. Now we can factor out a 4.
Mohan says nice, that's right now. Mohan says you got it right the first time, you only had this error.
Yeah. It's 12. So now we're going to put in 4. Boom! That was question number 1. Oh, jeez. Alright, maybe we'll be faster on these other ones. Let's try it. Okay, we have x plus 4 over root 3x plus 13 minus 1. We're going to multiply this by root 3x plus 13 plus 1. Okay, this becomes x plus 4 times root 3x plus 13 plus 1 over 3x plus 13 minus 1. So 3x plus 13 minus 1 on the denominator. Three x plus 13 minus 1. Okay. Which becomes 3x minus or plus 12. So then this becomes, and then we can factor this down even further to 3 out of here, x plus 4. Those cancel, so we just get 3 in the denominator. So this is root 3x plus 13 plus 1 over 3. So we have negative 4 plus times 3 plus 1 under that root 3 gives us to negative 12 plus 13 under the root gives us to root of 1 plus 1 I think my math went wrong somewhere. So it's 0. So then I want to see what's the square root of, obviously 1, so it's 1, right? Got negative 12 plus 13 would be positive 1. 0 divided by, oh, minus 1. I should be plus 1 on the outside here. Let's see here.
Mohan says 2/3. Mohan says it's 0.6667.
Yeah, that's what I
says
got.
that.
That's what I got, but I wasn't sure if it wanted a fraction here, if it was trying to trick me. So I got 2/3 for my answer. I got square root of 1 plus 1 equals to 2 over 3. That's what I got on my pen and paper here. But I wasn't sure if it wants a 2/3 here. Oh, it does. Okay. You can put in fraction. I didn't know it never asked for a fraction before. Okay, that's what I was confused on. All right. Okay, nice. We got that one. Okay. We want to find limit now. X goes to 1 of this one here. Or x minus 1. So this is going to become 5x plus 4 times, or no, minus 9 over x plus 1 times square root of 5x plus 4 plus 3. Okay, now we can reduce the 9 that down, so this becomes 5x minus 5 over x plus 1, 5x plus 4, 3. We factor out a 5, we get, or a negative 5. We get So on this one I get 5x minus 5 on the top. We factor out a we factor out a 5, that gives us to x minus 1. If I factor out a negative 5, does that give me negative x? I don't want negative x, right? So if I take root 5x plus 4 minus 3 times root 5x plus 4 plus 3 gives me 5x plus 4 minus 9. Then it gives me 5x minus 5. I factor out a negative 5. Doesn't that give me negative x plus 1? Plus 1. I want to see what they got for that first step. Come on, copy. Dude, no way. I copied the image.
Aurora says back to the math grind.
Hey dude, how's it going? We're about to switch over here. Okay, I copied image. Okay. Okay. Okay, I'm done. Why is it doing that? Dude. As it here. It's on my clipboard, you piece of crap. Oh, whatever. Guess we gotta solve our stuff.
Gina says hi.
Hey, Gina.
Gina says Cal King.
Does it have a solution?
Betsimp says 2S.
So multiply by 3. That gives us to 5x plus 4 minus 9. 5x minus 5. Oh, it wasn't x plus 1 in the denominator, it was x minus 1 in the denominator. Why did I put right plus 1? Okay, last one here. And then we'll be done with this session for math today. Okay. X minus 3 over.
Mahan says 2 will be 5. X1. X1. Conjugate of original numerator.
Minus 4. Okay. We're gonna go root 4x plus 4 plus 4. Root 4x plus 4 plus 4. This becomes x minus 3 times root 4 over 4x plus 4 minus 16, which becomes x minus 3 times root 4x plus 4 plus 4 over 4x minus 12. We're going to factor out a 4 to give us x minus 3. That cancels out that and that. So now if we plug in our 3 here to give us to root 4 plus 4 times 3 plus 4 plus 4 over 4. This gives us to root 12 plus 4 plus 4 over 4 gives us to root 16 plus 4 over 4 gives us to 4 plus 4 over 4 gives us to 8 over 4, which gives us to 2. All right. Dang. Okay, I'll have to come back and take some better notes here. All right, let me go to the bathroom real quick, you guys. I'll be right back, and we'll get into some working on our SpectroSim project, and maybe a Leet code problem. I'll be right back, you guys. All right, I'm back. Sorry, guys. Thanks so much for being here. Oh. Oops. All right. Cool. All right, let's go ahead and get back into the project here, yeah? So last night I did a long stream. Not a long stream, late night stream, my bad. Late night stream where we went and built some more of our project. So let's go ahead and pull that up. All right. So here is our current browser, or our current page, right? And we have the ability to go to simulators, absorb sim, and go to absorb sim. This is what we have so far, which is pretty cool. So I like this so far. It looks pretty good. Where do we even go from here? That's the question, right? What do you guys think we should build here now? Okay, so this is what we got so far. For the absorb sim here, this is that so it has, but on the nav, let's go to my nav. So on the nav, here, patty top, I remember that. Let me see. Okay. Alright, looks pretty good so far. I like it a lot. I think it looks really clean. Alright, that goes there. So we're gonna have that open up blank though. So let's go to our absorb sim. We're going to have this. Right, it's like blank. How do you make it go blank? What is the...
Aurora Zare says you still have your bathroom message up by the way.
I always forget, thank you. What is the message for... target? There we go. That looks good. That looks really good. Okay. So now... we need to, on our absorb sim, we have our compound search, right? I'm losing steam, you guys. Nope. Undoing buttons over here. I'm gonna blow my nose real quick. I'm losing steam, you guys. Okay, so we want to have, how do we want to do this? So obviously we have a graph here. Right, so this is what we have so far. SpectroSim home, about, simulators, absorb sim, compound search. This looks really good so far.
Mohan says Mike likes bathroom.
Right. Hey, how was the gym? What? Spectral data source from PubChem database. Okay, so compound search. So I guess we just need to we just need to throw on, so we have this div here for the compound search. Right. Compound search section. Then we have, let's say, what do you guys think? How should we style this? You guys have any inputs? Let me know.
Add Easter egg Mike.
Maybe when it's done we'll add some Easter eggs, but okay, so we have nav, got the compound search, right. We then need to add, obviously we need a place for the graph to be returned. Compound.
Mohan says Twitter.
Compound search plot generation. So okay. So there's some things we need to figure out is where do we want the plot to be?
Mohan says 4 more.
4 more subs? Oh, 4 more subs, you guys. Thank you guys so much for subbing along. We're 4 away from 2,200. I'm moving a little bit slow right now. I'm losing steam. My eyes, I'm just getting tired, you guys. Oh boy, I'm just getting tired. Okay, so I also want to have like a status. So if they search for a plot, so I'm gonna make this extra small, right? And then I'm gonna get a status message that's below here, right? So I'm gonna add in a paragraph.
Mohan says made card component.
So I want like a status message. Maybe next to the search, or should we have it be below? Like if I say like success, like search status. Insert some other paragraph here. Search status. Search status crop dot search status. So by default, let's go search status like here. We'll add in, rather than adding props, let's do just another paragraph. We'll add in okay, so this is what we're gonna do. Search status. And a in the paragraph. So do I want to say paragraph here? Or I want to say like.
Mohan says search result search result. NA. User says I'ma be like you after my exams. Keep up the work.
Property dot text. Hey dude, who said that? User, I'm gonna be like you after my exams. Nice dude, keep grinding. Yeah, I appreciate you being here. So search status, we say none. Like so, right? And I'm gonna give this class name here, we'll give blue.
Mohan says Mike do like me.
So we can make this search status go green or red depending on the status, right?
Mohan says add to see if it has result, if not show NA.
I want to make a...
Mohan says, wait, why though?
So we'll just say status none for now, that's fine. I like that, so pubchem status none.
Mohan says, if any results pop up, you know it's green.
What? I could change the color be green and red, just added more feature. Let's say blue. I like that. If I say, what's 500 be? Pretty dark. That's pretty good. Okay, so then I'll make this cyan 300 just so I can break up the link from the status. Yeah, that looks fine. Okay, so search status none right there. So when you search and you get a status, that'll change to success or fail, and I'll have that also change color. I'll have to figure that out as well. Okay, so then let's go ahead and throw on our plot, a section for our plot, compound search plot generation. So we're gonna have a div here. So obviously we just need an image tag. Basic test. Source equals to some source. So let me go here really quickly. Let's just go to here, run this. I'm going to take this plot really quick. It's going to copy.
Mohan says, Mike, doesn't she regret starting the dress shop and get you in CS? Eric says, we're off today.
Hey Eric, how's it going?
Mohan says, she should write LMAO.
Hey Eric, how's it going, dude? Yeah, today's a holiday for the U.S. For us U.S. folks, so we I was able to spectro plot. Coded a different time today, but I am tired today, let me tell you. I'm just lazy day today. Lazy day. We all like those days though, right? We did some Leet code, or we did some math earlier though. So let's go here. Public.
Says, just popping in, I think it's impressive how much material you're genuinely breezing through and applying nothing but inspiration. I need to step it up this summer, man.
Thanks, coach. I appreciate those kind words,
Eric
dude.
says, how's the Leet code grind going?
Nah, well, Leet code's okay. I guess we solve a couple of problems every once in a while when we want to, but I really like building the projects is what I really want to focus on because I want to get this one done. My goal was to get this one done before our 1 year mark, so that would be our 6th project done, like our second full stack, or yeah, second full stack project. So, you know, we have the Chroma plot, our personal website, task tracker, small business manager, inventory management, and so now we're gonna have SpectroSim for number 6. I was hoping to get that done before June, which is our 1 year programming mark, but I don't think that's going to happen. It's just too big of a project. This is going to be one of our bigger projects here. Okay, so now we have SpectroPlot within our here, so we can get this and so let's go.
Have you started applying to jobs?
I have not. I honestly I don't really know if I'm ready. I am pretty scared, to be honest. I'm not gonna lie with you guys. Repo SpectroSim front end.
Causiting says dang, only 1 year. That's impressive.
Yeah, 11 months so far. Hey Cozy, how's it going? Okay, so
Eric says I feel it bombed my last couple front-end interviews lol.
yeah, dude, I've only been doing this a year, so I have kind of like imposter syndrome. Like I don't even know. Like there's people that have been grinding this stuff for years and are failing, and so what makes me think I'm any different at just this small mark? So I don't know. It is. I do have some imposter syndrome here. You have to keep the Vite SVG in the public repo. Why do I have to keep the... That doesn't make any sense.
Causiting says it's going LOL, planning out some builds for a large Hobbit event in October, and then I gotta work on code stuff.
Nice, dude.
Mohan says oh, imposter syndrome is my skill, I listed it in my resume.
Yeah, dude, you guys are funny. Nice, dude. Do you go to like Comic Con or anything like that? So we have our plot here. So let's go. Okay, so the class, let's go round.
Causiting says nah, this is my first ever anything. I usually don't leave my house lol.
me either. Me either. Okay, we want to apply that drop shadow. So what I'm going to do is I'm going to wrap this though in a card. So let's go import card. How does it do this? Card. So So why can't I put in this card? There we go.
Mohan says, Mike, time to stop being lazy. Plotted on your site. Ira, don't show images. You can style the plot BG to match your SID.
Oh. Okay, so let's go. Leet. 600. I'm gonna take this shadow that's on my button.
Duardo says, is this paid or free?
What do you mean? Paid or free? How's it going, dude? Thanks for coming in, my guy.
Mohan says, what's paid? Mohan says he is making side brother.
Okay, so then if I also
Duardo says, oh. Duardo says, now I see.
okay.
Mohan says the database is free though.
Okay. Right, so we have a compound search section, compound search plot generation. This is what we're gonna do. Okay, so
Mohan says, what's lambda?
lambda is the wavelength. So wavelength is it's just a symbol that resembles wavelength. So then A of lambda is absorption at that wavelength. going to come here. Press search status. Okay. So then what we'll do I'm gonna have another generate, like a compound and then a button for generate. So this is what we'll do here. So on top of it's on div section for the actual image. Right. And then within
Mohan says, Mike, this will look very empty on desktop view. What more info you gonna show? Maybe also add a table every 50 nm. It shows the lambda and flex call on desktop, flex row on tablet and mobile. Mohan says 2 more.
So we got a div, and then we're gonna say paragraph here. Okay. Do another. Okay, and then we're gonna add on to here a button one. Compound. Generate. Okay, so I want to give this button. Can I override this button's width? Or
Mohan says, generate text too big, don't you think?
So then we'll say so this is gonna be search button. I'm gonna say I'm gonna rename this search. Compound search button. This will be alright, clock that. Okay. Right. So then compound project. So I'm going to go
Mahan says, couldn't you remove the pxpy and everything in button 1 and copy the style of search button and add to its class when you using it?
Maybe. It's alright though. Like if I go to the generate plot button, if I remove this, and I go here and I add it on, no, it doesn't apply here.
Mahan says, weird.
For example, so you have to allow external styles to merge.
Mahan says, oh, I guess BC your PX is for text, but when you add it there it will become for the button itself.
Like that better. Okay. So then in the absorption we have,
Yumang says, hello, Mike, good to see you.
hey dude.
Please send out the resources you are using to learn this like PDFs. Keep it going.
Yeah, dude, I've already done that. I got everything in my Discord link down below, Yumeng. So feel free to join down there. You can get access to all of the PDFs, books I've read so far, notes I've taken live, links to my my GitHub repos for those, course breakdowns by the week from CS50 courses, community whackathon or hackathon events that we're going to do, projects, all that kind of stuff. Now I like that. I'm gonna leave it there. Okay, next. So I'm gonna say generate absim.
Yumang says, thanks. Mahan says, number 1 more sub.
Oh, gotcha. Generate the absorption. looks pretty good. Okay. One more sub. Anyone? $21.99, guys. We're one sub away from 2,200, Gina. One away, you guys. Thanks so much for joining me here.
Losing it.
I'm losing it for sure. I thought you were talking about the padding. Okay. Okay, so now what do we want to do, you guys? What do we want to do? What do we want to do? What do we want to do? What do we want to do?
Mohan says he is like YTF uppercase makes the button too small. Mohan says XD. Yumang says congrats on 2,200. Mohan
Hey! 2,200. See if I cap a screenshot here. Thank you guys so much. Yeah, 2,200. It's been a long time coming, you guys. Just grinding away here every single day in my room, teaching myself Python and computer science, mathematics and programming. Thank you guys so much. If you guys have any recommendations of things we should learn or what we should, tackle, feel free to let me know in the Discord. Someone unsubbed, rip. Trolls out there. Okay, so my idea with the form, we lost two, boys, it's going quick. The idea with the flow of the project is that, right, you have absorb simulator where you can insert a compound name, right? You'll press search. The status will say like loading, and then it'll say loading or whatever, and then when it has successful search found, it'll then say success, and then this will change to like green, right? We'll change this to green and it'll say success. And then we have loaded compound. And so once it says success, the compound name that was loaded will get generated right here. And then you can generate the absorption from there. So you can search to pull up the information, and then you can generate an absorption from that by pressing this button to actually pull that plot. So that's my thinking. I'm thinking that maybe we could save a little bit of bandwidth. Like maybe they don't want to generate a plot right away. They want to search for the compound, see if it's even there. Okay, load the compound up into the queue basically, and then generate the absorb sim off of that queue, Rather than just having it be like one universal button, we can have some flow to where they search, they populate. Maybe we have off to the right here, I'm going to list the individual, I'm going to list kind of like the JSON information of the compound that was loaded. Right, so to the right here, I'm going to have some information regarding the compound that was loaded, like the lambda max, the name, the various, the database information we pulled from, right, and then you can generate off of that data and pull the graph.
Hand says make the status hidden unless they press search.
No, I'm going to say just none for right now, because there is no status right now. Until they press search, it'll say success or fail, or just none for no search right now, or pending or whatnot. When they press search, it'll say loading, and then when it loads it, it'll say success or fail. But when you're just idle here, there is no status. It's none. I mean, we can make the whole bar indicators like be hidden, but we'll worry about that when the time comes for the JavaScript.
Aurora says, are you gonna let people put in info themselves in case the API is down?
Yeah, so that's gonna be our other feature. So they're gonna have a compound search section to actually search the API, right, and get successful or failed searches, and then generate absorb sim plots on those searches within the database, or below here, they could generate their own by inserting their own custom values. Right, so that was going to be the second part. So I'll have the plot go off to the right here with some compound information pulled from the PubChem, right? And maybe I'll just go ahead and maybe what I'll do is I'll also use my regular expression to actually parse like the description of the compound. So we're also we'll give like the compound name, a short description of what it is, some general and then the actual absorption or UV data statistics that we have kind of outlined here to the right, and then to the left will be this part here, this section here. I think that's a good structure. What do you guys think? So to the left will be this loaded compound and generating absorption plots, and then to the right will be on compound search, right? That'll be what was found, and then you can actually generate, or maybe we'll have it be off to the left, and then the compound plot is off to the right or whatnot. So it kind of flows from left to right. So you search, you generate a compound, and then you can generate the plot that was loaded. And we might put this at the bottom of that, what was found, right? So then you generate, and then it loads the plot to the right. I like that. Okay, so let's go ahead and really quickly here before we kind of wrap for today. Let's go ahead and do that then. So we have the compound search plot generation. Flex row. And then this is the
Mahan says lead time mic a variety stream.
No, my lady's still here, so I'm spending time with her while I can. Okay, so we have hold on. Compound search plot generation.
Mahan says, today, no night stream?
I got work tomorrow. It's Monday, it's not a weekend, it's a special day. Okay, so what am I doing? This is closed. Okay, this is that div. Okay, right. So the plot generation flex row. You have this. That's weird though. Why is this? Oh, because it's wrapped in a div here. Okay, got you. So we'll say flex row. And then here is going to be the div for the found information. So
Mahan says press Option Shift F, it will auto fix it.
Option Shift. Oh, I don't have a formatter right now for JSX. I'm using black for Python. Compound. Okay, so the div opens up. Okay, we're gonna have div here.
Mohan says prettier works for all.
Pretty works for all. Okay. So flex row. Okay, so then here what we're gonna do is we have a div for, and we'll say here it's gonna be h1. Oops. We'll say found compound with some text. Okay. And now we're gonna have paragraph. Okay. We'll need to fix that. So we need to set a predetermined width to this. Let's see, it's a quarter. Then I go. Oh boy, it's starting to get really nested here. Okay, so this is for this. So then,
Sandkill says, mobile first.
okay. Then here, give a class name. No. This is half. I'll have to add in some wrapping. Because I want this kind of be more right here. Compound. So what I'll actually do is I'm going to take this div here out and replace this H1 like so. There we go. Okay, so now you have this. The only thing is so I'm just gonna give it the half. Flex row wrap. So we're actually gonna say this is not gonna go paragraph. So, we're gonna say H1 here. Put in like so. Okay. Okay, so then I'm gonna take the generate plot button. Okay. That's here on this div. Huh. Okay, so we have test compound. This is the divs ref. This is half. fit this container. So if I want to give some spacing to the button here on the bottom, right? Now what if I actually remove the card? That kind of looks more clean. I kind of like that. So if I give a class name here and I go flex, flex column, like this button, my button is stretching to fit the container. Fit on the button. There we go. So now if we say flex column gap 2, now we have gap. Perfect. Okay, that looks pretty good. So what I'll do here is I don't need to do this. This one empties. This one's for the full page, including the compound search. So if I put this guy here, flex wrap, space, okay. If we apply kappa 2, what if I you give a gap y to say 4. We don't need a gap x because we don't want to push those any further apart. Okay, that looks really good. We had a lot of improvements so far, you guys. I didn't think we were going to get this far. Okay, so we have a kind of a compound name here. I need to make that text bigger for 1. So class name here, this is going to be text 2XL, XL, text, we'll say bold, bold. fold. Fold. Compound search. I'm also going to have that. Test compound. Generator absorption. That looks pretty dang good to me, guys. What do you think? What do we think about that so far? I like it. Add. Make sure we got our contribution. I totally contributed yesterday. I think it's like East Coast, West Coast time differences. All right, this is what we got so far. Where we have the ability to generate, or not, we don't have the ability, we're just laying out this forms, right? So we have a test compound, we have the name here, a generate absorb. So when you search a compound, you'll get a status that'll change to success or fail, depending on its status of the search. The test compound will then be populated for the compound name that was generated, and then you can generate that absorption sim, and then the information here will also be populated and changed. So we'll apply some like UV max, or we'll apply like lambda max, epsilon max, sigma, and some other, like just the general information here, and then have that, and then you can go on the bottom and make your own, right? I'll have like a make your own section. This looks really good so far. It looks really, really clean and professional. The colors look really nice. I think it looks really, really good. What do you guys think? Let me know. I appreciate you guys being here and joining me. I think I'm going to call it for today. This was a 2 hours and 45-minute stream session where we first did about an hour of calculus work, learning about factoring using limits, or factoring down our limits, our equations to solve for limits and whatnot. And then we also worked on the front end of our spectro sim here, where we got our absorb sim page to have not only a compound search area with a button here, some spectral data source from PubChem database, a search status. We added in this test compound, or this compound kind of info area, and then a plot to generate the absim. Short stream, 2 hours and 45 minutes. What are you talking about? All right, you guys, thanks so much for being here and hanging out with me today. I'll potentially come on later this evening if I have some time to do a part 2 or an after-hour stream. It's not going to be as late. I cannot stay up until 1 or 2 a.m. like I did last night. I will not be able to function at work tomorrow. So I'll maybe come on around like 9:30, 10:30 for just maybe like an hour or so to do another session, and start linking up sort of our buttons with our, what we need our site to do, which is actually, search for the compounds, do these status updates, populate the information and whatnot. So we have a lot of actual programming to do, not just styling and web app stuff. So thank you guys for being here. I'll be here. I'll see you guys a little bit later tonight, or potentially maybe tonight, or definitely tomorrow. I stream every single day around 7 p.m. PST after my 9 to 5 job as a chemist. My name is Michael. I'm 26. I got a degree in human biology and a minor in chemistry. And like I said, I work as a formulation chemist from an 8 to 5 every single day, and I stream afterwards. So thank you guys so much for being here and joining me tonight. I'll see you guys a little bit later this evening or tomorrow for sure. All right, guys. We all pushed up our code. Let's make sure we're all good. All right, I think we're good. All right, thank you guys for being here. The site looks really, really good so far. I really like it. I think it looks awesome. So I'll see you guys later.